Welcome back to the course. In the context of green process engineering, we should also mention the bioeconomy of water. Water is at the epicenter of social economic development and is responsible for the success or fail of each and every sustainable development goal, often shortened as SDG. SDG are the heart of the 2030 Agenda for Sustainable Development, an initiative presented by all United Nations member states in 2015. Water determines food and energy production, industrial output, the quality of our lives, and the environment where we live. The slide presents water stress indicated in percentage values of different countries versus population density, indicates in inhabitants per square kilometer. Access to clean water is under threat in many parts of the world due to the pollution, overuse, and climate change. Through the International Atomic Energy Agency support, more than 90 countries have used nuclear and isotopic techniques to find, study, and protect water resources, which helps policymakers develop water protection and management strategies and plans. These efforts contribute to achieving the United Nations Sustainable Development Goal 6 on clean water and sanitation for ensuring access to water and sanitation for all. Here the water stress of different countries versus GDP and worldwide water stress versus population density and GDP based on each continent is graphically presented. Yet, water scarcity and inadequate access to clean water remains among the most urgent, pervasive, and impactful problems afflicting people throughout the world. Along with population increase, economic growth, and shift in consumption patterns, which have intensified the demand for water resources, the inability to recognize the real value of water is possible, the main cause of its reuse and waste. Against this background, valid strategies for implementing a circular economy approach in the water sector are still in their infancy. In order to establish a deeper picture of water circular economy around the globe, the Water Circular Economy Index is introduced based on 3 pillars: decreasing, optimizing, and retaining a water circular economy to assess water use circularity and efficiency in different countries across the 6 continents. It becomes evident that most of these indicators are targets of SDG 6, clean water and sanitation, highlighting their significance in the water management and circularity context, as well as their direct relevance to achieving the Sustainable Development Goal 6. Rather, charts for 4 selected countries and the 6 continents are illustrated in figures A and B respectively. As observed, the different continents and the selected countries, Singapore, South Africa, Peru, and Turkmenistan, exhibit diverse scores in each indicator. The Water Circular Economy Index for different continents is calculated based on the population-weighted contribution of each country to the overall Water Circular Economy Index for the continent and is shown in figure C. Oceania and Europe emerge as the leading countries in terms of water circular economy, exhibiting the highest scores, and they are followed by North America and South Africa. In contrast, Africa and Asia display overall water circular economy values below 0.5, indicating lower performance in this regard. Ultimately, no circular economy of water can be pursued without fully integrating such a scheme without the management of the other global resources necessary to modern society. No circular economy of water can be pursued without fully integrating such a scheme within the management of the other global resources necessary to modern society. For example, to reach zero carbon emission, carbon capture and utilization processes can and should be integrated with wastewater treatment plants, via single or multiple integrated approaches such as microbial electrolytic carbon capture, microbial electrosynthesis, microalgae cultivation, constructed wetlands, and biochar production. A possible example of such a holistic water circular economy model is shown in this figure. The only possible mechanism by which a long-lasting and sustainable management of water can take place in a growing world with limited resources must operate according to a circular model where each individual drop of water is reused, recycled, reclaimed, recovered, or restored, and where water losses are simultaneously reduced from the very beginning. However, establishing a circular economy of water as a self-standing grand design is likely to fail unless it is appropriately integrated into a broader global approach that also addresses the management of all the essential resources on which humanity depends. The life cycle analysis case study demonstrates, for example, that replacing fuel or gas-based energy supply for water purification technologies with cleaner, renewable solar energy can have side effects such as terrestrial ecotoxicity, freshwater ecotoxicity, and urban land occupation. Global freshwater use and management represent only one of the planetary boundaries which humanity is asked to correctly manage for sustainable future, and this can only be achieved via a holistic global approach, integrating water among the other key resources needed for our existence. In this video, we learned about bioeconomy of water, Sustainable Development Goal 6, clean water and sanitation, differences about the water policy and water access between the countries of the world, and the Water Circular Economy Index. This brings us to the end of this video. Thank you for watching, and I'll see you in the next unit.